quiz. How do we do the first one? All right, so do the reciprocal, so 6a over b times b over 3a. Good, now what? Reduce bb. Yeah. So what are we left with? 2. That's right. Is that okay? What about the second one? Okay, what should I do with the first one? Factor r out. X plus r over x squared times x over x plus r. Right? So what can I cross out? X plus r and one of the x's leaves us with r over x. Is that okay? Yeah? No? Why not? Yeah, factor, reduce, factor, reduce, factor, reduce. How about the last one? Right, so we have to square the second one. What does that give us? X to the fourth, a to the sixth, because we multiply exponents. And then start crossing out, so a squared, how many a's do we have left? 4, right? 2 and a 6, subtract, x cubed. So that gives us x cubed over a to the power 4. Right? Well, you subtract exponents. Because really what it means, a squared is a times a over x, and x to the fourth is 4x's over 6 a's. So you can cancel one at a time, and you'll get x cubed and a to the fourth, right? Of course, that's an overkill. That's why we have rules of exponents. What? Are you talking about that? No, okay. Because you were very passionate about something. What? Okay. All right. Well, I have a problem for you all to do. It's a numerical computation. And I want you all to do that. 1/2 minus, what do I want? 1/3 over 1/4 minus 1/6. Compute that for me. I'll give you a minute. little. It was there to just inspire. Well, no, your mind just got blown, and that's the whole purpose of higher education. You've expanded your horizons, and you might become a magician afterwards. Now, let me show you something. 1/2 minus 1/3 over 1/4 minus 1/6, right? So we all got 2 out of that, which is correct. And we had to do subtraction of fractions and all that. You can throw it out. I can make plenty of those. So we had to find the common denominator, and that's no matter what we do, we have to find it. But we can use it more efficiently. So if I were to ask you, can you find the least common denominator for all of the little fractions, what would that be? 12, right? 12 would be the smallest number divisible by 2, 3, 4, and 6. Do you agree with that? So what I'm going to do, instead of subtracting the numerators and denominators, I'll just do that. I'll multiply everything by 12 over 12. Is that legal? Yeah, I can multiply by 1. Now see what happens. I have to distribute 12 through that numerator. What is 12 times 1/2? What do you think? 6. And what is 12 times 1/3? 4. So 6 minus 4. And what is 12 times 1/4? 3. And what is 12 times 1/6? 2. So in one move, we got rid of all the complexity in our fractions. So what is that? It's 2 over 1, so that's 2. Right? It is fun. Because, again, as somebody pointed out, if I put fractions all over that thing, I mean, not fractions, variables, it's going to get really hard to do it the way you did it originally by actually combining the numerators and denominators and then see what you get. The best option is just to clear out all the denominators by multiplying by the LCD. Okay? So the idea here, let's just practice this. Did you understand how we did that product? How we did the distribution? And we can do this computation in our heads. We don't have to write it out and reduce. You should be able to go, 12 times 1/2 is 6, and 12 times 1/4 is 3, and so forth. Is that all right? So here's an example. Let's just play with that distributive property. So let's say I have AB and then 1 over A plus 1 over B, like that. It's not even a fraction, it's just an expression like that. So if you distribute AB throughout this parenthesis, so AB times 1 over A, what will cancel? A. And what are you left with? B. So this first product just gives me B. So B times whatever the numerator is. In this case, it's 1. So it's B times 1 is B. How about the next product? What will cancel? And what are you left with? A. All right. So that's it. Are you okay with doing that part in your head? That distribution and canceling the denominators? Well, no, because this is AB over 1, really. So AB goes in the numerator, 1 goes in the denominator. All right, let's try that one. So let's say if I have something like this, x times x minus 1 multiplied by, so let's say 2 over x minus 5 over x minus 1, something like that. But again, when you multiply by an expression that does not have a denominator, that means you only have a numerator, it's over 1. So it only multiplies with the top, not both. So when I do this expression times the first fraction, denominator should cancel. So x's will cancel. If x's cancel, what is left? x minus 1, but there's also a 2 from the numerator. Okay? So you're going to get 2 times x minus 1. That's what we're left with. X's cancel, so you're left with whatever's in the numerator times whatever's left out of that outside term. How about that? What will cancel there? And what is left? 5x. So minus 5x. We can distribute that, so it's 2x minus 2 minus 5x, so minus 3x minus 2. If it didn't cancel. But are you okay with that process, how we reduce? Because again, we're going to apply it to the so-called complex fractions. If I had something like this, let's say 5 over x, well, okay, it's a little slightly different, minus 2 over x minus 1 over, I don't know, 1 over x minus 1 plus 3 over x, something like that. Okay? So that's what's given to us. This is so-called complex fraction. So we have fractions inside the fractions. So what we're going to do, we'll first look at each individual little fraction and find the LCD for everything. So what is the LCD for everything here? And x, right? X and x minus 1. You need both of these factors. Okay? Now, since we're multiplying a fraction, I have to multiply by 1 or multiply and divide by the LCD. And I think this is what you were asking, Nicole, earlier. Is that kind of what you were asking when you said numerator and denominator?
Yeah, but from this problem looks like it aren't easy.
But are you still confused? You're right. Okay. So anyway, so when you're faced with a fraction like that, that has many little denominators, find the LCD and multiply and divide by that LCD, and then do kind of what we did here. Distribute that numerator through the numerator and denominator through denominator. Everything will cancel. The little denominators will go away. And we'll just take one step at a time. You don't see what? The written? Oh, okay. Yeah, so what she's saying. But anyways, so just like the previous example, we're distributing, yeah, you're right. We're distributing x minus 1 through that numerator. So this is similar to what we just did here. Okay? So if you just focus on multiplying x minus 1 by 5 over x, what will cancel? X, and what's left? X minus 1 and whatever's in the numerator. So 5 times x minus 1. So this is what's left out of that first product. How about the second product? When you multiply by the second fraction, what will cancel? And what is left? And there is a minus, so minus 2x, like that. Yeah? All over the same process. X minus 1's cancel on the first product. We're left with just x plus, on the second product, what's going to cancel? So 3 times x minus 1. So in that one move, we got rid of all the little fractions. Our complex fraction became just a fraction. Right? And considering how much you like fractions, that's just a huge improvement. Right? I mean, that's just something more humane. And then you just do your math. It's 5x minus 5 minus 2x over x plus 3x minus 3. And combine like terms. 3x minus 5 over 4x minus 3. So that's the final answer. There's nothing else you can do about that. So this is equivalent to what I did with that problem when we got 2. If you want to try to do the same problem the way you worked it out, it's going to take forever. It's going to be very hard to do. Okay? So you're always better off clearing out the little fractions. And you do that by multiplying and dividing by the LCD, and then do that distributive trick. So all the denominators should cancel. Isn't that fun? Okay. Well, we'll spend probably the whole of Thursday talking about that. But let's talk about your upcoming test. Don't you have a test coming up? The syllabus suggests that your exam is on October 17th, which is a week from Thursday. Okay. So that means, so that's the exam 1. So October 15th is the review day. And we're right on schedule. We just have to finish talking about those complex fractions, and we're good. And that's what we're going to do on Thursday. Now, exam, as I told you before, but I'll repeat it again, all problems on the test will come from your worksheets, homework, quizzes. So every problem on this test you've solved, potentially, if you've attempted all those assignments. So a good place to start is kind of look over some old stuff. Yeah.
Will you get like a review of like a worksheet?
I don't know. Because, I mean, it's just stapling old worksheets together. That's really, I mean, I'm not saying it's going to be that huge, but it's, expect anything on that test. But no surprises, because you know, I'm not going to pull up a problem that you haven't seen before. Maybe for extra credit or something. I'm not sure what you mean. Oh, you will get the cubic ones. That was the deal. The 4 cubic formulas. The sum difference of cubes, cube of the sum, cube of difference. You owe me the 3 quadratics. Difference of squares, square root of sum, square root of difference. And that's all you need. We haven't done anything else as far as the formulas are concerned. So I give you 4, you have to know the other 3. You can bring one. I mean, you're probably not going to need it, but... What? The what deal? Oh, I don't know. You think about it. Remember the deal. If there's certain errors that make me very upset, like this, you know, if you do that, that makes me very sad. And then I'll, you know, that makes me sad, and what makes me absolutely crazy, and I'll just make sure that nothing good comes out of your test is that. If you do that, I see one of those, I'll grade the rest of your test with extreme prejudice. And yeah. Oh, you got it. I mean, come on. That was the whole, we spent like, what, a month talking about that? Right? This is not true. Do you agree with that? What am I missing? Well, not everything. I'm missing one thing. 8x, right? We're missing 8x. So yeah, it's x squared plus 8x plus 16. So gotta be careful with it. So yeah, the abuse of those formulas make me mad. Put me in a bad mood. So yeah. So there are 2 things that will, yeah, that, and if you start canceling where you shouldn't. So yeah, the worksheet solutions are all on Canvas, so you can look at those. The homework solutions are on Canvas. The quiz solutions are not on Canvas, but they're on the Canvas class notes, because we've gone over every quiz in class. So all the solutions are up. Well, I mean, maybe except for the few, some of the last ones. So I'll put them up later today. Yeah, good. I'm going to give you a worksheet now. No,